The brain neural networks are used for storage and processing of the visual stimuli coming from the outside world. In our model, we use a two-dimensional game field, or picture, which reflects the geometry of the three-dimensional 3D environment. We then unfurl the donut and turn a 3D object into a 2D plane figure. During the first lessons, the students learn the rules of the CTOR game and hold a class championship using a table version of the game. In this part of the course, they play against a computer. Artificial intelligence, or AI science, is engaged in the creation of artificial systems that copy the functions of individual brains. This approach is similar to the algorithms used in the logical games such as chess and Go. Our students will be the first to test algorithms for the logical game CTOR. CTOR game is a mathematical model of a real environment. Chips are like organisms. Their behavior is similar to the behavior of real creatures. The laws of their movement and survival are analogous to the real processes. Such models do exist in real life, where the human brain and social skills have been developed. Each student will be able to assess such brain characteristics as logical, imaginative, and intuitive thinking. Unlike the other puzzle games, CTOR always allows the participants not only to play, but to evaluate the cognitive type of different players, as it is shown in the picture using the complexity scale from 1 to 100. The more actions a player can make in a single move, the more difficult the game becomes, and so does the game's decision-making mechanism. Each specific set of rules corresponds to a number on the scale. For example, the desktop version corresponds to number 7. This version of the game against the computer does not have time limits for the player's move, so we use it for training purposes. In one move, a player can put 2 chips and move 2 chips. The computer replaces chips once the move is completed. When the player's move is completed, it will be a computer turn to move. All the chips have a limited lifetime, which is reflected in the color shades of the chips, from bright to pale, when it dies. Students learn how to build a winning strategy. The two most prominent debut variations are the network and block. Network means control over all the fields, with the alignment of the chips across the entire field. Block means forming a block structure which cannot be destroyed by the opponent. The IQ, or intelligent quotient test, exists for more than 100 years. It's used for the evaluation of an individual's logical thinking. We use our own CTOR-based test, which allows us to evaluate logical thinking, associative and creative thinking, and intuitive thinking. Each cognitive function is activated at a certain level of difficulty in the CTOR brain game. The CTOR brain game offers the following settings: duration of the game, chip's lifetime, leg up for a player before the game start. Different combinations of these parameters require different types of thinking. There are several ways to calculate the level of thinking in the CTOR game. In the classroom, we use the third variant shown in the picture. Each student moves up to a new level of complexity in case he or she has won in the previous round of the game against the computer. Test results of the classroom test correlate with the results produced in a real game field. This means that we now have an objective technique of measuring the mentioned types of thinking. Our CTOR game allows us not only to measure the participants' logical and intuitive abilities, but also to evaluate a phenomenon known as collective intelligence. This will be discussed in the third part of our course.